Why one machine can stop an entire factory in highly interdependent operations. At 6:17 a.m., the line is running. At 6:23 a.m., one machine slips out of sync. By 6:31, the factory is no longer running. It is waiting. One machine does not have to break dramatically to stop a factory. It just has to become the point where everything else has to pause, reroute, slow down, or ask permission. Because a factory is not a collection of machines, it is a chain of dependencies. If one station fails, the next station starves. If one buffer fills, upstream flow backs up. If one inspection step stops, product piles up. If one approval is delayed, the line keeps moving nowhere. So the question is not, why did that machine stop? The real question is, why was the entire factory vulnerable to that one machine in the first place? That is where the hidden cost begins. A single machine can stop a factory when the operation is built around fragile timing, narrow buffers, and too much confidence in recovery speed. Leadership sees output targets. Operators see the jam. Maintenance sees default code. But the real failure is usually somewhere between them. The machine was not the only thing that failed. The decision chain failed too. Someone knew there was a recurring issue, but the warning was buried in logs. Someone saw the pattern, but the escalation took too long. Someone understood the risk, but the line had to keep moving until it couldn't. That is how small problems become expensive ones. A 45-second stop can become idle labor. Idle labor becomes lost throughput. Lost throughput becomes overtime. Overtime becomes delayed shipments. Delayed shipments become customer pressure, and suddenly, one machine is not just a maintenance problem, it is a business problem. This is why factories do not collapse all at once. They bleed. They bleed through micro-stoppages. They bleed through weak handoffs. They bleed through, we'll fix it after this order. They bleed through systems that recover just enough to make the risk invisible. And that is the most dangerous kind of failure, the one that looks normal because it keeps coming back. So when a single machine stops production, the real story is rarely the machine itself. The real story is how much of the plant depends on one weak point, and how long the organization has been pretending that weak point is manageable. That is the operational truth. One machine can stop an entire factory when the factory has not been designed to absorb failure, when the buffers are thin, when the handoffs are slow, when the data is scattered, when the people know more than the systems do, and when everyone mistakes temporary recovery for real stability. And that is why one machine can stop an entire factory.